Hello, everyone, and welcome to today's webinar. We're going to talk about from the cloud to the core to the edge and how to make 5G end-to-end network slicing a reality. And first of all, I want to thank you, the audience, for joining us today. And what promises today is to be a very interesting discussion with a demo of a real-world end-to-end slicing proof of concept by some of the biggest thought leaders in the industry on this topic. What we'll do at this point is actually kick it off with an introduction to the presenters, and then we'll come back and have a discussion around what it means to do end-to-end slicing. And Oleg, as you'll see here, will talk about what their vision is and how they see it, and Kaloom and Itential will share their thoughts around how their respective technologies can be a huge contributor and an enabler of end-to-end slicing. But before we do all that, let's go ahead and meet the presenters. So first of all, I'm Roy Chua. I'm the founder and principal at AvidThink, a small research and advisory firm in this space. And let's go ahead and have Oleg introduce himself first. Oleg, if you could introduce yourself.
Thank you, Roy. Hello, everyone. My name is Oleg Borzin. I'm with Equinix. Equinix is one of the largest or the largest provider of data center and, very importantly, interconnected services around the world. I am my title is Fellow Technology and Architecture in the Office of the CTO. Thank you.
Thank you, Oleg. All right, up next, let's have Suresh introduce himself. Suresh, if you could.
Hey, my name is Suresh Krishnan. I'm the CTO of Kaloom. And we've been working very closely with Oleg and Chris over the past few months to get this end-to-end 5G slicing demo done. I'm really glad to be talking with Roy too. Roy is always a blast to talk to. So really looking forward to this. Thank you.
Well, likewise. And I noticed that you all have the requisite patterns behind you, but Chris does not. He has an abstract painting. So I just want to point it out. Now, I have none behind me. I have this, screen I stole from a Chinese restaurant, but there you have it. Chris, if you could introduce yourself and maybe tell us where you actually are.
Sure. This is Chris Wade. I'm the CTO with Itential, and Itential is a network automation software company, and we focus on automating networks of all types, and we're going to talk about 5G slicing today. And unfortunately, I don't have my pets in the back. I'm in a hotel room today, so we'll go from there.
Yeah, that's okay. We believe you, Chris. And just, I think for the audience, I think that the team has known each other for some time, so there's a good discussion. And I usually see Suresh and Chris Wade are my closest conference friends. I always see them at conferences, and it's been like that for the past 9 years now, maybe. Wow. You guys are getting old. Kidding. Anyway, so with that, let's get started. And hopefully today will be enjoyable. And the audience, we would encourage you to ask questions. So go ahead and ask questions. I think we have a lot of experts here. The brain power here in this virtual room is tremendous. And if you have questions about 5G end-to-end slicing or how something like this can be valuable or useful to you in your initiatives, go ahead and please ask. And these guys, I've worked with them for some time now, and they are clearly some of the brightest in the field. So let's go get started with the slides, just to set the context. All right. So 5G and differentiated services, why is it important? And it is important because unlike some of the previous generations of mobile technology, 5G comes with the ability to provide differentiated services for different use cases. Whether you want highly reliable, low latency networks, or maybe you're looking for just a lot of bandwidth, or you're looking for all of the above, right? 5G provides the underlying capabilities that allow that. And so the belief, and actually some of the early evidence shows that businesses may be willing to pay for that type of service, and that's why it's key to monetize it. Because 5G, after all, we're looking at tens of billions and hundreds of billions of investment by telcos. I think if you look at the aggregate capex over the next 4 or 5 years, you're getting to $1 trillion worldwide. That's what the GSMA says anyway. So that's a lot of money going in. And so how do you get it back? You need a return on investment. You can't just put money into the network and not be able to make it back. And so in order to get the ROI, you do need the ability to charge for differentiated services. And so what do these differentiated services come in the form of? Certainly the SLA capabilities, right? Better controlled latency, jitter, throughput, reliability, isolation from general traffic. And there are a bunch of use cases that can benefit from this, right? Obviously gaming, Industry 4.0 use cases, emergency services, the connected vehicle, and eventually the autonomous vehicle, self-driving cars, healthcare, right? And in order to get these differentiated services, you need the capability to do network slicing. This end-to-end orchestration and allocation of resources across the board are what allow you to provide this level of differentiated services. And obviously, it's not just about the network, but also about the coordination with the edge computing and storage resources. And so in order to do this, there are some key unlocks, right, that include the scalable and efficient network traffic for your user plane traffic, right, as well as an end-to-end automation component across all these network elements. And these are obviously not the only elements of it, but those are key elements to unlock the value of differentiated services in the network. And before I turn it over to Oleg, I just want to point out that this is not just limited to public networks. It's also applicable to the situation where private 5G is used in enterprise networks or in controlled networks as well. And so everything that we've said today certainly applies to public mobile networks, but also to private networks. And so with that, I'm going to turn it over to Oleg, and he's going to paint a vision of 5G network slicing architecture. So over to you, Oleg.
Thank you, Roy, and thank you very much for the introduction. Yeah, as you pointed out, the focus, the topic here is the kind of end-to-end view of network slicing, but I would say the focus here on providing continuity of network slicing. So in other words, we're not trying to solve the problem that the mobile operators are and the technology providers are already solving in terms of, creating slices, signaling, and all the machinery that is associated with initiating slicing in the mobile network operator domain. And in general, if you at the highest level, we could think of network slicing as basically grouping of functions and their interconnectivity in order to deliver services under specific performance kind of constraints, be it latency, throughput, or error conditions, or functional constraints. So for example, hybrid multi-cloud connectivity from a 5G device to basically connecting to edge compute and to clouds could be a functional requirement for a slice. But here we're making a few observations, right? From the Equinix point of view, an entity that often sits in the middle between the operators, clouds, customers, and edge compute providers. Certain observations that come to mind here is that even though the mobile traffic originates in the mobile network operator domain, it's not contained within the mobile network operator domain. In other words, this leads to this concept of the slicing must go on. In other words, we want to make sure that the slice performance, the slice characteristics extend all the way, from the origin of traffic to where the traffic wants to go. And often it wants to go to the clouds or to optimally placed edge compute. So the second point, the second observation is that the resources of the slice, specifically when we say network slicing, the keyword network does not refer to the network layer functionality. In other words, network and interconnect only. It also refers to the functions that comprise the slice. And, one of the most critical functions is the user plane function, as you pointed out. So this, the optimality of placement of these functions with respect to the slice performance requirements is very important. And if you take that notion and apply it to the UPF, this leads to the need of placing the UPF optimally, right, with respect to the end-to-end flow of the user plane traffic. And that's an important requirement. The third one is more of a functional. So we do believe, just like in today's landline, so to say, set of requirements, hybrid multi-cloud access is going to persist in the 5G world as well. In other words, because and specifically when you pointed out the private 5G networks or public access, using public 5G to access private applications in the cloud, it's still a standing requirement. So hybrid refers to the introduction of a edge computing resources. And here on the slide, we loosely refer to edge computing as MAC, but we don't imply this 3GPP compliant MAC. This is the basically, call it multi-purpose edge compute or edge compute in general. And then the ability to also access multiple clouds. So just like in today's world, many enterprises basically distribute their backend functionality across multiple clouds and internet destinations, where this will carry over into the requirement of accessing the same applications, from the 5G device, but benefiting from the performance enhanced by slicing. So, and the final observation here is that because this is in its nature, a multi-domain environment, right? So we're talking about the operator domain with all the machinery that exists there, edge compute domain, interconnection domain, clouds with multiple clouds. This is not a simple environment, so therefore, it needs to be made simple for consumption, right? And automation is the key enabler for that simplicity. Right, so see what you see here in the slide is basically what we were trying to show in our demonstration. And the three slices here kind of illustrated. The green one is closer to the low latency or even ultra low latency. We're not claiming that this is ultra reliable and low latency. It's just basically the ability to create a low latency path between the device through the optimally placed UPF and edge compute, right? And you can see here that there are a couple of choices of how this, specifically the user plane function, could be instantiated. One is the state of the art today, which is basically deploying the user plane function on bare metal with all the, I call it the layer cake type of challenges that come with it, deploying the bare metal itself, installing the operating system, installing the virtualization, acceleration, techniques, deploying the UPF software itself, provisioning. So that's not a simple proposition. What we're actually focused here on a technology that enables to kind of, instead of placing the UPF, I refer to it as activating the UPF on the network fabric. And specifically, we used Kaloom to show this concept where a programmable network fabric has the capability of implementing both the user plane functionality of the UPF plus the control plane requirements for the M4 interface in order to talk to other functions within the packet, within the 5G core. And here, you'll see in this jagged kind of rectangle in the middle is where we actually used Kaloom Fabric to activate the UPF functionality within it, and basically becoming a direct extension of the layer 2, layer 3 interconnection fabric for multi-cloud connectivity. And really, basically the third slice here is something that could be a general purpose type of interconnection, between the 5G devices and multiple clouds. We do not assume that the mobile network operator control plane exists in the same location. It's just all these functions expose their signaling and management interfaces to the 5G core, and also on the top, the orchestration or automation element is represented, by Itential. The working acronym for this, we called it NICE. This is Network Slicing for Interconnection of Core and Edge, and this is what we implemented for the POC in our environment. Next slide, please. So this is more of a how we did this, and really we represented this as a architecture that has domains and layers, right? So domains here we see the enterprise customer, specifically relevant to the private 5G access. The operator domain, this is the mobile network operator. In the middle, of course, this is the interconnection domain, which is enhanced with the ability to activate the user plane function itself, and specifically the bottom part here where it's activated as part of the interconnection fabric and is interfaced directly into the global interconnection fabric that can then provide continuity between the UPF and the, for example, application functions or applications that run within the clouds, as well as connecting to the edge compute resources. So here, in a nutshell, what's happening is that we emulated the process where an enterprise customer is asking an operator to deploy 5G access with basically two slices. One slice is for it's actually two customers, one slice each, and each slice has the edge compute connectivity, local, with low latency, and then the connectivity to the cloud, and a combination of their all. So basically, what we're initiating all of the provisioning through an API call that communicates something that is not formally the network slice template, but is pretty close to it. And that template says, okay, so the UPF needs to be created in a given metro. So the orchestrator decomposes the request. It activates the virtual slices in the network fabric, including the user plane function. It then passes control over to the Equinix Fabric. Equinix Fabric creates connectivity to clouds. It actually reaches out into the clouds, and here we used AWS and created all the logical functions for VPC, virtual gateway, BGP, and then we completed that loop end-to-end with end-to-end traffic, including the ability to send traffic to edge compute. One of the interesting part here is that this architecture actually allows to meet some of the requirements for network slicing templates, where, for example, the latency between the last UPF and the application function could actually be expressed as a requirement and implemented here, and utilizing the optimal placement of functions and connectivity, even without explicit QoS. It's something that's possible due to the proximal locations of all these functions. So the next slide, please. And this slide kind of talks about where, right? So everybody's talking about the far edge, micro edge, near edge, but this is a map of the Equinix data centers. This is the United States view. The dark smudges that you see on the map are the urban metropolitan population areas, and the dark circles are rough estimates of about 10 millisecond round trip time, from the Equinix data centers to the circumference of these circles. And if you count the number of people and their GDP in those circles, it will come out roughly to about 80% of urban metropolitan population density and GDP. We didn't count how many businesses and enterprises, but it's a large percentage. So what the point of this slide is that we could start making this concept a reality with basically kind of bringing together the 5G access, the enterprise ecosystems, and optimal and proximal infrastructure placement in this architecture, right, to realize some of the promises of 5G. So at this point, I'll turn it over to Suresh for the Kaloom part.
Thanks, Oleg. Thank you. So just like following up on what Oleg said, I think the key part, as Oleg mentioned, is really the programmable fabric, right? It allows us to build start with the lowest layers like L2, L3 support for networking, and then start building stuff on top of it. And one key thing that we did pretty early on, and we always wanted is to build slicing into the fabric itself, right? So since we have a programmable fabric, we can actually put slicing as a first-class primitive in there. So this means that not only is the networking layer, the L2, L3 split, but everything that we build on top of it, for example, the UPF we have today, and the virtual routers we can run in there, everything can be sliced, right? And that allows you to build a complete end-to-end slice through the system. And it's a small example here. So imagine there's a data center, and you want to use it to build something like an enterprise 5G network. So on the left side there, you see some kind of corporate campus. It's got manufacturing stuff like Industry 4.0, stuff like that. And there's also regular engineering and administrative pieces in there as well. So we can take some kind of RAN environment over there and aggregate it towards a data center that's pretty close, right? Which is in this case, it's 4 millisecond away. And what you can do is we can start slicing and dicing the amount of resources sitting in the data center between different entities. And because the slicing itself is implemented natively, you can do this at a pretty high granularity and total isolation. So in this case, we have 3 slices. One of them is going towards a company. One of them is towards like some kind of carrier. So think of like an operator you can think of. They get a slice of it, right, based on how many G-Node Bs they want to connect to it, how many customers they want to connect, and what kind of throughput they want. So they can get a slice both towards the RAN and towards the transport side based on their needs. So this could be something that can be provided really as a service. And also, a lot of the enterprises are also trying to use public cloud systems. So the idea would be like you can have a mix of public cloud, private cloud, and on-prem resources. Like if you look at like Oleg's picture, the MEC, the edge compute kind of stuff. Like so, you can have a mix of resources in the data center, as well as like in the public cloud, as well as in the operator network, to do all kind of things that are possible. Right? Depending on the application, some of them might require local termination. Some of them might require like ending up in a more cost-effective place to handle the data. So you're allowed to be. It's easy to do all those things when you can actually start changing the pieces together and decide what services need to get enabled. Next slide. So another key features, right? Like the programmability is one piece, but the other thing we're trying to think of is like really efficiency, right? So like since we get closer to the user, the power, the real estate and cooling become like very, very, I would say critical in being able to fit the resources that you need. So what you're trying to do is like squeeze in as many functions as possible into the networking fabric itself. So right now we have the UPF in there, virtual routers, so we can do like BGP and OSPF like directly inside the switches, right? The forwarding of the packet doesn't need to hit a server to do it, right? And we also want to do like more access termination, like fixed access termination and so on going forward, like with the BNG or AGF stuff going forward. And the third piece is really the transport side, and that's something we already have as well, like doing stuff like MPLS, L3 VPNs, and so on. It's also something that you can just enable as a service, right, without requiring additional footprint for taking care of these networking overhead services. And the key idea again is like this is sliceable. So the idea is like you kind of like think of it as like pay as you grow kind of thing. So you can turn on the services as and when needed, and until then, like they really don't take up any resources in the system. And that's like the key piece, that you can actually add services while you can turn on services as you go along, and we can also add services when need comes up for like newer services which we don't know about today. That's something we can also turn on with a software update on the system. So thank you.
Thanks, sir.
All right. Over to you, Chris. Yep.
I appreciate it. So I'll start off with a few observations. When we think about 5G and slicing specifically, we think of it as really the first kind of network that can't be managed by humans alone. So it's an exciting time for automation in general. And I think as we look through the multi-domain aspect of the slicing topology that Oleg was working through, I think it becomes very clear that our historical way of automation, kind of doing it domain by domain, is going to be less applicable here. The convergence of network and cloud is really kind of driving innovation in the space. Just looking at, it's an exciting time for networking just because the amount of innovation from vendors like Kaloom providing software-centric solutions. I spent a lot of time with Roy talking about SDN and NFV over the years, but the most important part, or the most important aspect of that from our perspective, is how programmable the network is. So the ability to really onboard these technologies, operationalize them. And I think most people would agree that it's fairly complex. And as we adopt more and more of these technologies, the complexity continues to increase. So from an Itential standpoint, we think it's part of our responsibility to not only operationalize those technologies, but attempt to simplify them from a northbound perspective so that they can be consumed by both enterprises and application developers that are trying to take advantage of these networks. As Roy was going through kind of the first slide, really the potential benefits of 5G are only going to be realized once we can really allow application developers and enterprises to take advantage of all this awesome stuff. So from an Itential standpoint, I think some of the guts in the platform you'll see during the demo is really around the integration flexibility. We've gotten to the point now where we can do runtime integrations. So people provide, Swagger-based specifications, and some of these modern network platforms really allow us in runtime to integrate with all of these systems. Back to that kind of architecture slide, the volume of integrations that Oleg and others want to plug into this platform over time continues to grow and change. So the days of having very fixed kind of OSS inventory and activation type of aspects are gone, and we really have to, as we move towards the cloud, adopt more of an API-centric way of automation, and having integration flexibility is probably the most important aspect of that, because it's how quickly we can take advantage of new technologies from folks like Kaloom that really allow us to move fast. So from that implementation speed perspective, whether our software is deployed on-prem or in our SaaS offering, it's really about how much stuff we have out of the box. So we have like 110 integrations now. We'll talk about how quickly we onboarded some of these technologies, but really the ability to move fast is really one of the key things I want to talk about here. And then ultimately, what types of networks are we talking about? I mean, we're talking about cloud networks. We're talking about some wired networks. We're talking about virtualized networks. These things have historically been siloed, either through standards bodies or how we operate these networks. But really, it's becoming, especially in this slice world, it's really a combination of these technologies, and most operators or consumers are less concerned about which one's a CNF and which one's a fixed asset. It's how quickly can I take an innovative product to market, and how can we consume all this innovation that's coming. We really think we're in the early days of innovation in the networking stack as we move towards software. So we're really focused on how we can kind of operationalize and onboard these technologies. And then ultimately, as we talk about scale, I think some of the estimates around slicing scale are some of the largest lifecycle estimates of most networking stacks. So really the ability to scale independent of the kind of type of network that we're going to leverage is going to be super important. But kind of transitioning into the demo, maybe we won't go through all of these just because we're gonna see the demo here, but it kind of gives you a concept of the variety of platforms involved, the number of capabilities that Kaloom exposes that need to be taken advantage of to set up both a fabric as an underlay and the UPF and ultimately the slice. And as Oleg said, integrating that slice both on the front haul side with where the user's coming from and back to the cloud interconnection where the application's going to live if it's not on the MEC site becomes very important. So hopefully in the demo you'll see some of that simplification northbound so that users can take advantage of it as kind of a network API. But really the variety of integrations and kind of the complexity of what needs to happen to set up the slice, but provide it to the end user in kind of a simple format. So Oleg, I'll turn it over to you for some of the nice specific POC environment where we ran this.
Sure. Thank you, Chris. Yeah, so as Chris said, so transitioning into the actual setup of the demo. So what we've done, this is all based on the Equinix data center in Silicon Valley in US West. It's directly adjacent to the US West availability zones from major cloud providers, and also making use of the internet exchange in that area. So just to illustrate the practicality of it, the latency from the back of that virtual UPF inside, or the slice inside the Kaloom fabric, to the customer's VPC in the availability zone in AWS was about less than 2 millisecond round trip time. And this is really speaking to that optimally placed infrastructure point or observation that was made in the beginning. But what we constructed here is what you see in the middle is basically the Kaloom fabric was deployed using white box switches, and the switches are, I believe they were edge core switches. Sorry, and running Tofino ASIC, right? And that is the P4 programmable data plane. Those switches run under the Kubernetes-based control plane. So this is an example of cloud-native networking. Edge compute was directly attached to that switch fabric, and the same switch fabric was attached to our Equinix fabric node in that area, and from there we have connectivity to clouds, the internet, and actually global connectivity from there. Well, we didn't do the global provisioning; we just basically connected to the local cloud, which represents the concept of once you receive user plane traffic, you want to get rid of it as soon as practically possible with the least performance penalty to the network, and that's really what we're achieving here. Right. The control plane was simulated, so and the UE and the G node B, everything was simulated by using a simulation package, and we pretty much started with automation. So effectively, what happened, you see within the programmable fabric, we created two slices that appear to be pink and kind of lavender in this picture, but these represent two customers. Each slice consisted of a user plane function, virtual layer 2, layer 3 routing, and then had connectivity to edge compute, generic edge compute, not 3GPP MAC kind of compliant, but generic edge compute application. And also, we orchestrated, this was not touched by any human, orchestrated interconnect, virtual interconnect into AWS, and we actually created automatically two AWS VPCs and BGP peering all the way to the pink and lavender layer 3 virtual routers, and then all the way to the back of the UPF, and showed end-to-end traffic going through this environment. So in the next slide, there is what Chris described. Next slide, please. Yeah, the automation actually consisted pretty much utilizing the, I think I'm referring it correctly, a composable end-to-end automation engine that Itential provided. So basically, within 6 weeks, about 4 to 6 weeks, we were able to integrate all of the required netconf payloads, so that the Kaloom fabric could be initialized and configured. Virtual fabrics could be created through this automation gateway, and then the Equinix interconnect fabric APIs were integrated as well, as well as the AWS cloud APIs. So all of that kind of took without actually coding. Let's say that I don't think there was any actual code development. This was pretty much integrating netconf, integrating existing API adapters. That's to the point that Chris brought up, is that this automation platform kind of basically ingested existing APIs just by simply downloading the Swagger file and pretty much creating what's called an adapter in the Itential platform. One of the very, very interesting points here is that, as you'll see in the demonstration, the automation flow was actually a workflow with controllable steps and data structure normalization. So between netconf and structures inside Kaloom, what's required, string fields, values, and things like that, creating the all those components like lags and termination points, layer 2, layer 3 virtual routers, and the UPF itself. Equinix is a different set of APIs, but represent different data structures. So everything was normalized. And AWS, everybody knows it's a different, completely different API structure that exists there. But everything was normalized across, including at the workflow level and the data level. And the workflow, it was really a composable workflow with validation checks, user authorization validation checks, including the integration with the Office 365 for notification and end-to-end kind of BGP connectivity verification. But the important part also, as you see at the top here, that all of that workflow was wrapped into effectively, and that's what we used in the demo, a REST API call. Right, just summarizing all of those functions and exposing high-level parameters to the user, and basically creating that call. It's not really yet the formal network slice template that, like I said, that was kind of triggered during that call, but it's pretty close to it, and that's really what created that slice, two slices themselves, the interconnection and the end-to-end kind of validation. So I think that describes the demo. And Roy, I'll turn over to you for the short video.
All right, thanks, Oleg. All right, at this point, I think we've seen a sort of exciting description of what is going on here. And what we're going to do is going to start a video. The video is going to run for about 4.5 minutes, and so we're going to play that video, and that shows the demonstration of all that you've just seen. So all those slides and all those architecture diagrams were made real in this demonstration of an end-to-end slicing. And so let's see how nice is slice or slice is nice. So that's yeah, good acronym, Oleg.
Yeah, it's actually our username was Nice Slice.
Nice slice, right? Now I can guess the password. So let's turn over to the video and get it started. All right.
We start the automation using the tenant provided topology and can see the different parts of the configuration as they are created, including port assignment and reservations, naming assignment, and any lag connectivity if necessary. All layer 2 and layer 3 information is applied as the topology continues to be built out. The automation tool allows the operator to capture audit data, identify incoming parameters, and review outgoing data for each of the tasks along the way. The audit is always available and is essential for trouble resolution. With the vFabric creation complete, let's move back to the high-level view and see the steps associated with the ECX AWS connectivity. We start building out the tenant's AWS VPC connectivity using the ECX buyer API. We then create the topology across the path and finish back on the AWS side. From there, we establish the layer 2 and layer 3 connections to match those we created on the nice network slicing fabric side. This screen shows the vFabric directly connected through ECX to AWS US West 1 from Equinix Metal in Silicon Valley. The buyer side VLAN ID and the seller side are also both confirmed, with more information related to the order details listed below. Let's take a look at how it appears on AWS Direct Connect. Here we see the connection is established and available, along with the ordered bandwidth. The BGP information shows the ASN of the vFabric, the local and remote IP information, and confirmation of BGP peering. We are now confirming the VPC has been created. The routing table shows local destination and the mobile pool prefixes of the MEC servers connected to the vFabric and the 5G UE IP address range. Let's move to the second slice. This tenant requires 5G UPF, so we will add UPF configuration to the same automation we did on the earlier vFabric. As soon as that is complete, all that is left is to verify the BGP sessions and routing tables. Once we verify that peering is established and the routes are received and in place, the Outlook integration will send a success email to interested parties. We have a successful config install and can close the automation and move to the 5G component. The 5G piece is centered around the UPF function, configured and activated as a service within the vFabric slices. Here is the topology representation. The Itential Automation Gateway defines the packet forwarding control protocol information used to manage communication between the 5G core and UPF. Now it is time to send traffic through the completely configured system. We will use Emblasoft's solver software to simulate the 5G traffic. Traffic will be sent to MEC servers S07 and S08 through the newly configured vFabric 2 and existing vFabric 1, showing examples of local 5G traffic breakout and access to edge computing. Data transfers begin once all the control sessions have been established. In this demo, the sessions disconnect as soon as the defined traffic patterns have been completed. This is how the flows look against our topology diagram. Let's move back to the Kaloom fabric to see the statistics that were generated as the 5G traffic flowed through the system. Starting with 5G devices, through the simulated radio access network, and off to destinations on MEC bare metal hardware, VPCs, or the Internet. We can see the Internet traffic flow with the first flows from the 5G UPF to vFabric1. We see the traffic is received from the UPF and sent to the local MEC server. Likewise, we see the same traffic pattern in the vFabric2 statistics.
Excellent. That was a cool video, cool demo, end-to-end, real packets being sent, real stats, unless Suresh was shoving those packets through the pipe, really quickly, and Chris was, tweaking the count, like bring it up.
I was watching them closely, so they couldn't do it.
You were, to make sure it was in sync, right? So as he's shoving the packets through it, it's like, that was pretty cool. But very good. So, welcome back. And at this point, I'd like to ask the audience, go ahead and submit questions. We're going to have a brief discussion around what we just saw, right? And maybe just to reiterate some of the points and some of the highlights. But in the meantime, we'd like the audience to go ahead and submit questions as well, and we'll take those. And just, feel free to go ahead and submit those questions. It's not every day you actually see a real live demo of an end-to-end fabric slicing that has a cool name. Nice, right? Anyway, so let's go back and look at the demo. That was pretty cool, right? So it actually showed the ability for the Itential automation solution to take those APS interfaces in there just as Swagger files, get it all visually presented nicely, and then to see the traffic flow through. So I think one of the key things I think we saw was it going into AWS, and that was quite impressive. And obviously it's Equinix, so it's low latency because you have those paths. Do you see, MNOs starting to use these things? Obviously it's not productized. It was a proof of that could be done. But, what's your perception on how this might be used by MNOs?
Who do you want to start answering?
Let's have you start, Oleg, and then we'll maybe have Suresh.
Yeah,
I'll give you only the hard questions. It's proportional to the number of patterns you have behind you.
Okay, those are abstract, right? It's a good question, but I think a well-known secret here is that I guess the right-hand side of the picture is used day in and day out today by the enterprises, right? That everything you see here is in the enterprise kind of world. Yeah, it's called public cloud, but the reality of it is it's the virtual private cloud, and every one of those has the a IPv4 RFC 1918 CIDR, right? So we're basically, IPv4 space. So all of that stuff is to say that customers already moved on to really placing their backend in clouds, and more specifically multiple clouds, right? Because that requirement already exist, and because every carrier that that I know of has services specifically for basically trying to connect these customers to their cloud backends, and in every case it's a challenge. So by having the ability to have this fixed site connectivity automated and streamlined and pretty much using optimally performing infrastructure is very important. So then, enter 5G, what are we going to do, right? If there is a 5G device that requires access to a CIDR inside one of those VPCs, then really there is no magic. We have to solve for enabling that 5G device connector. If that 5G device happens to be a high-speed enterprise router using fixed wireless access, then it doesn't make sense to trombone this traffic through a distant UPF. Therefore, being able to place this UPF next to that interconnect point and to the cloud access point is very important. More specifically, then the question is, how do you place this UPF? Then if there is a method and a way of doing it, as we've shown, as part of the interconnection fabric, that becomes really very powerful. So this could be one of the real use cases where, if a carrier or a private network provider or a technology provider or an MVNO has this problem, right, where, the traffic needs to be optimally routed and connected to multiple clouds, and, by the way, stop over to an edge compute. What we didn't show there is that edge compute was actually based on what's called Equinix Metal, which is a also orchestratable bare metal service where you can bring up bare metal and load your applications on top. So this could become a real use case for specifically when we talk about enterprises, gaming, and the one other thing that wasn't really kind of brought out is that UPF inside that fabric is performing at an order of magnitude greater performance, like in terabits in terms of a number of sessions, right?
Right.
So that's, I see it as a very real.
Right. Yeah. So it makes sense. I mean, we talked about 5G, talked about network slicing, but like you point out, it's a real problem, and it doesn't matter how you get there. I mean, it could be a wireline connectivity as well, and you still need that high speed fabric. You still need that connectivity, and you still potentially as well, right? So converge access, things of that nature as well. There is a related question here. It's got to do with multi-MNO. So the question is, how do you envision making this a reality in the multi-mobile operated domain? It could be challenging unless the MNO standardized the definition, implementation, and characteristics of the network slices, right? We always talk about slicing, and we kind of know how to do it. We talk about it in the generics. The specifics are still in process. Anyone want to take that question?
I can take like the introductory part of it, right?
Yeah.
So if you look at this, yes, I completely agree that the complete standardization of slices is a very challenging thing. But if you look in practice, right, what did we just show? Right, we showed a function, like the user plane function, like placed optimally relative to the user plane traffic flow, and an orchestration of an interconnection of slicing continuity. So assuming that we can start with something of a least common denominator, where carriers create whatever slice variants they want, but at the interconnection level and user plane level, there's only a certain number of parameters that we care about, right? Is latency, it's throughput, and it's segmentation, right? And basically, those basic things could be enabled in a multi-carrier domain, in a multi-carrier manner, because they are common to everything.
Yep, fair. Suresh?
Yeah. So Oleg, I'm surprised you didn't talk about the PCEI stuff like that you're doing too. So Oleg is like too shy and modest as well, right? So this is stuff happening at Linux Foundation, right? Like the PCEI blueprint stuff that like Oleg is leading. That kind of tries to like set down some of these things together, right? I think the real catch is, right, like not that like how each of the MNOs can do it, but imagine when you have like roaming scenarios and stuff like that, when people have to understand like what somebody else is doing. I think that will be like, I would say, the real hard part to do it, right? But I think as like, if like Oleg said, if you can parameterize it, it becomes like pretty straightforward, right? And if like you look at it, like if you look at like how, like if you look at Chris's slide, like how the fabric is seen, right, by the orchestration system, then it becomes straightforward to distill like what somebody is asking for, as long as the definitions are agreed. And I expect like somebody like GSMA would probably come in and like provide some kind of interconnect service between the operators to standardize like, what the profiles of stuff is going to look like. I think that's probably the most likely way that is like interoperator would be supported.
Yep, I think that makes sense. Chris, any thoughts on this?
Yeah, I'll take a little bit of a different perspective. I love the standards. My concern is that waiting for the standard before we start publishing these things is my concern. So I would just recommend everybody be open and publish their APIs to consume and use their services. And I think the standards would benefit from seeing real life work. Too many times the standards are a boiled down version of what's possible. We don't see public cloud providers agreeing on standards because they're trying to differentiate in the marketplace. And I would just encourage everybody to publish their APIs. The technology at this point is so awesome that the integration cost is not what it used to be. So while there's obvious benefits of like handover and what we've done with MEF and some other things, publishing APIs is kind of the starting point, and we should just get on with it.
Yeah, no, I think it's fair, right? I mean, if I can pick from a menu on Equinix, and I say, I want jitter, it's sub 5 milliseconds, I want latency, sub 2 milliseconds, if I want bandwidth, this, I just pick 3 or 4 parameters, as Oleg was saying. Then you give me a price, and I say, yes, let's go. Here's Chris's credit card. Let me swipe it. Sure. And then I go ahead, right?
Yeah. But I also think that there is a sort of a common ground in what is in network slice templates, right? Some of it is very standards, like sophisticated, but some of this is self-explanatory. Like if customers or enterprises want a certain latency profile between the last UPF and the application function, that's exactly what could be templatized, right? As it's very practical.
Yeah. Yeah, no, I think go with what the customer's asking and what the customers are looking for, and it's as long as there's enough customers, you can't be wrong, right? Because that's where the money is. Right? Let's see, next question coming up, just a good one. We talked a little bit, but not a lot, which is there any impact on the BSS and OSS and applications platforms? And if yes, what are those? And how will the telecom operators, how are they planning on coping with that impact going forward? So any thoughts on network slicing, on BSS and OSS impact? Someone want to start, Chris?
Yeah, I think it's pretty massive. But I don't think it's necessarily slicing. I think it's the introduction of virtualized and containerized network functions. Right, for a long time, the center of OSS was inventory, and it was a very static, fixed type of asset database, and we started putting logical stuff in there. But if we create a UPF and it persists for a couple hours, should it be in OSS? From our perspective, the Kaloom controller is the source of truth for those fabrics. So I think you hear the word federated a lot, and I think that's a key aspect to it. But I think when OSS and BSS is a large word, so I think there's more dramatic impacts on certain parts. But I think we need to rethink more of a federated, distributed notion of this. Rather than a highly centralized, static, fixed type of concept. But when it comes to actually billing and stuff, I think the BSS side probably is less. I mean, how we sell and productize things, I think, is independent from kind of how we orchestrate the network.
I think that's fair. Yep. No, I think it's fair. I think number one, yes, it is massive, and how you bill for it. The other part too is this is the assurance portion of it, right? Which is that, I paid you for this amount, right? And you promised me less than 5 millisecond, 99% or 99.9% of the time, you got to prove it to me, right? So that assurance portion or that provability that I gave you what you said. Now, obviously, you could sell it and then wait for the customer to complain and say, wait, you didn't give me that, right? But ideally, there'd be an assurance component in there to validate that you in fact gave the customer what she or he was looking for. Good.
It's really important, Roy, right? What you touched upon. I think this assurance component is going to become very big, right? If it's not pretty big, right? At least in the enterprise domain and so on. I think the other trend we're kind of not talking about here, but it's something that's happening, is the containerization and microservices and so on, right? So the way applications are getting built has changed totally, right? To do the service assurance on something that's built using 10 components instead of one, it becomes very, very complicated. Let's put it that way. Right? So we need some kind of telemetry, which is not like yesterday's telemetry. So this is not just the NetFlow or IPFix stuff from where we can do some bulk
S-Flow, Suresh, S-Flow. Yeah. Forget P4int, S-Flow. No, I'm kidding.
Yeah. So I think the idea is we need to build something in there, and I think it all falls back to the programmability. I think Chris was talking about it, right? We can enable that. So we have this thing called in-band telemetry, right, where we can actually trace packets through the system, look at how each packet was treated. What queue it went into, how many other packets were in the queue with it, and so on. It kind of helps troubleshoot stuff, especially when some SLA stuff is not met, right? And that I think that's going to be critical going forward, that we have an orchestration system, for example, we need to be able to tell Itential that some SLA is not getting met, and Itential needs to be able to set the SLA on the system. I think that's also going to be a very, very critical part of this going forward.
Yeah, no, and actually that leads into the next question that we have coming up here. And audience, feel free to keep putting your questions in there. We'll try to get to all of them. If we don't get to them, we'll still try to address them, after the fact. But next question here is, does the network slice adapt to network conditions in real time, or is it static? And I think that relates to what we just talked about. You want to continue your answer, and then maybe Oleg or Chris want to jump in?
Yeah, I can at least take part of it, and then I'll let Oleg and Chris go after, right? So at a given moment, yes, it is static, right? But it's fairly dynamic. So when we have, let's say, the vFabric or any virtual function in the programmable fabric, it can change very, very quickly. So all it takes to add more resources to a slice is like a netconf call. So if let's say Oleg decides he needs 25 more gig for a given enterprise, it's like a workflow engine just tells Itential, and Itential just sends add a port into the vFabric, right? Or if they want another UPF, right? If they want new UPF sliced up, it's another netconf call. So it's I would say very, very dynamic, right? But it's not self-adjusting is kind of out of this thing, right? We can do it self-adjusting, so we could probably look at telemetry and decide hey, I need to provision more, but that's really outside of the system now. So it's more in the orchestration platform. So probably Chris can address that, right? So they can be this closed loop automation that will kind of do this, but the slice itself can grow and shrink pretty much at will, right? This is not static in any way. So it's not you configure it once and it doesn't change. It's always one call away to add and add more resources.
Yep. No, agreed. And I say, Chris or Oleg, going to add anything to that dynamism of the slice?
I would just make it even bigger, because at the end of the day, it's about getting asynchronous event feedback from whoever to make decisions on how we treat the slice. So I think at the network layer, we just think about looking at alarms, or looking at in the old days, just looking at percent of bandwidth on a port and making a decision on whether we add to the lag bundle or whatever. But I can get application tier feedback. You guys were talking about observability platforms. As these applications are running in hybrid multi-cloud environments, they can maybe forecast what's going to happen. They can give me feedback, and based upon those events, we can make decisions on how to either spin up or spin down different aspects of the entire slice. So, I think those platforms are getting a lot better. So it's about the trust and confidence in the end customer to say, I'm willing to make these network changes based upon these observations from these other platforms, which I think most people are getting there. So
yeah, no, I think we are. Yes. Oleg, you want to add anything to that?
Just very briefly is that, we actually need to understand, what degree of dynamicity is required for a slice, right? And actually maybe look at it in a slightly different dimension. So practically, if, this slice or these slices were created on the West Coast, right? And the customer's application exists, for example, across in the East availability zone as well, right? So being able to just simply replicate those slices, right, without changing their, network characteristic dynamically necessarily, is a big issue, right? And that part is something that could be enabled because their infrastructure is in place, the fabrics are in place, the capabilities are in place, and that's, I think, is very important.
Yeah, no, I think once you put the foundation in, right, for the programmability, for the automation, for the telemetry, right, then the key thing is what do you do with it, and how smart can you make it, right? And there's a question here that's coming in. I think it's probably our time for our last one here, but we need less of a question than observation. Observation speaking of, we need observability across infrastructure, network containers, VNFs, applications, and as well as the RF, right, the radio conditions for true end-to-end down to the UE level. And I think that speaks to some of the things that Suresh was talking about and Chris was talking about, right, which is this end-to-end, right? And all your example of the application sitting in say a North Virginia data center, right, and traffic sort of going back and forth. How do you deal with that? How do you look at the full scope of it and be able to tune the network to give the quality of service and the SLA that you provide, all the SLOs that you promise, right? And I think that's going to be the key going forward as we make this happen. But I think what's cool, and sort of wrapping up here, and thank you for the questions. Keep those coming in. We'll try to address those up, after the webinar's over. So audience, thank you for them. your question will not go to waste. So just keep them coming. But in the meantime, in terms of wrapping up, which is what excites me is in order to get there, and I think, as Chris was rightly pointing out, we can't just sit here and just talk and just, say, yes, this is great, right? Slicing is great. Slicing is great. You actually have to go out and do it and get customer involvement and say, this is one way we could do it. What do you think? Can you use it? How would you use it? That interaction with real world customers, real world use cases is important, showing people what's possible, the state of the art, or state of what's possible. And I think what's nice about NICE really is the fact that it actually shows end to end. It's actually working, right? I mean, obviously simulator, but emulator, but you can use a real UE, and it'd be interesting to see that, as we go forward. Hopefully you guys will get it to take it to phase 2 or next step or whatever it is, because I think that's what's needed. Because people can think in the abstract, right? That's Chris and his background, right? It's abstract, but when you make it concrete, right? Then people see things differently. Then it triggers conversation, it triggers actual thought, right? And then they like, oh, it's real. Oh, you mean it's real? Oh, okay, I see it now. I can actually do this and do this and do this, and that's when the ideas and innovation come. So really exciting demo, really exciting to have you guys all come together and do this. And in terms of wrapping up, thank the audience for having been with us the last hour, and hopefully you guys found it helpful. And any last words, panel?
No, just I mean, it's if you look at it, it's a unique combination of the fundamental infrastructure, the programmability, and cloud native networking and composable automation. And again, we're not claiming the actual end-to-end or creation of slicing the mobile network, but helping those go on. The slicing must go on. So that's, I think, is a very nice way to finish up.
I think we'll be with you right there. And the slice must go on.
Yeah.
The slicing must go on. We'll have to figure that one out. I'm not good with grammar, but but thank you again. Thank you, Oleg. Suresh, Chris, always a pleasure speaking with you guys. And audience, hope you found this enjoyable too. So we're signing off. Bye for now.
Thank you.
Thanks. Thanks all. Bye.